His family's around here, and you saw the little kids, so forth, dancing last night. They got here in time for that. Going to explain the principles of this motor, and then rev it up for you, and then you'll be able to come and take a look at it after he closes. Let's close the back door, please, and please eliminate the talking in the back of the room. If you want to leave, that's okay. Please go on the outside or out in the hallway to continue with your conversation back there. Wait a minute, too much back there. Yeah. Please in the back. Thank you very much. Okay, welcome Dr. George Freebot. Will you please? Thank you.
Okay, that one stays here, or use this one? No,
This is a recording. That's for the PA. That's for the room.
all right. Usually I'm here speaking about oxidation and ozone and oxygen, similar to what Ed has been doing, Ed McCabe. But today I'm going to show another form of oxygen, or utilization of oxygen. It was kind of interesting when I first saw the mechanical oscillator working. I was quite impressed. The inventor had it on his table. I went over to, or reinventor, went over to his shop and I said, let's do one of Tesla's patents, take the patent and just duplicate it and see what we can do and see if it really works and see if some of the principles that he was talking about worked. And as I was saying that, I saw this covered object on his workbench and I said, what's underneath that cloth that you have on the workbench? And he says, oh, that's a Tesla Mechanical Oscillator. And that was my introduction to it. What it is, and the way that Tesla was using it, he called it a self-acting motor. There was an article that he wrote called The Problem of Increasing Human Energy, which is quite a good article. If you ever have a chance to see a copy and read it, do so, because he addresses a lot of issues that ranging everything from world hunger to energy production. And in it, he talked about the self-acting motor. That's what this is. We've been doing testing with it. We brought a small one down with us also that we had hoped to have making electricity, but we couldn't get it set up in time. And that's what this is, a small version of what you're going to see running. The self-acting motor that he spoke about, he also used to run a turbine. He also used it to run, let me just get a picture here. It says, latest form of Tesla oscillator combining in one mechanism a dynamo and steam engine. And he used it. He also ran electromagnets on the ends of the shafts. What we have, I have a video also that people can view if they want to. It's about 10 minutes long or so, that has the fellow that remanufactured or redid this invention, and he explains it in depth. These are exhaust ports. You have shaft on both sides, and you have a single piston inside. There's no lubrication that's used, no oil, just some bearings on the end. Currently nylon, Teflon is what we've been working with. And what he was doing with it, and the testing that he's been doing, is a pump on each end. And what he does is he takes the compressed air, puts it into the mechanical oscillator. As it exhausts out of the exhaust ports, the air is actually cooler. And you would expect it to be warmer being a compressor, but the single piston, because it's compressing air and the same air is also used to push the piston back the opposite direction, what it does is it actually cools the air. Then he takes the exhaust, puts it into a pump that sits here, one on each side, and 4 stages, and this pumps the air down to liquid oxygen, or liquid air. And then he runs the liquid air back through a heat exchanger, which heats the air back up, puts it back into the oscillator, and it runs on its own compressed air. He's been doing different experiments with it and has found that about 3 gallons of liquid air will produce 10 gallons of liquid air when put through the heat exchanger. So that what basically he's doing is extracting the work energy out of the air and turning it into viable motion, mechanical motion. One of the neatest things is it's non-polluting, there's no lubricants, and virtually it's frictionless. So I'm going to turn it on. Hopefully I'll be able to get it started as easily as he does. Why don't we put it on the floor? Why don't we can set it on? I forgot how powerful it was. That was only about 4 pounds of pressure too.
You take the tape.
Yeah, okay. I'm gonna put it right on the floor. We have a meter on here. The meter, at times, depending on the meter on the air compressor, will disagree. But this is the actual poundage in pounds per square inch that are going into the oscillator. That's about 25 pounds of pressure. Also, the compressor is only running at about 20 pounds into it. When it runs at 75 to 100 pounds of pressure, you can't even hold on to it. I mean, it'll walk. We had two really burly fellows that were holding it down in the movie that we have in the video, but you can see what it's doing. What we have is a stroke. It's about 20 cycles per second. If you were to put magnets on the shaft and run it through coils, and Dr. Tesla stated that when you take a magnet and you put it into a coil, in and out of a coil rather than in a circular motion, you produce a power much more efficiently. And that's what this does. It's like I said, it's a motor that runs on air that will virtually take the pumped air from its own output and turn it into liquid air, put it through the expansion unit, and then it will actually run itself. So we've been doing tests with it. We have, like I said, a smaller version I was hoping to bring with the electrical output on it. As I was speaking with Walter about the unit, he said hopefully the next time that we'll be able to show it to you, we'll actually have the power output on it. We were hoping for that this time. The pumps are already built and have been tested, and it's just an amazing to me, and also to the other people that have seen it. It's an amazing unit in the fact of the power of it. It's just extremely powerful.
You say when you turn off the air, once it's going, it'll run by itself?
That's when the pumps are on it. When the exhaust, which is what these ports are, and it's only running right now on one input. It has 3 inputs. It's 3 times more powerful. I mean, we can't even run it up. We can't even run it up to where it should be. When it's up around 75 pounds of pressure, it was bouncing a huge metal table as well as this. I mean, just all over. It's very, very powerful. What it does is it takes the exhaust here, puts it into another pump, which sits here, one over here. That's what the grooves are for here. And then the pumps pump it down another stage higher in compression, okay, and extract that much more work out of the air. Okay, then that air gets cooler, and it just keeps each time it gets cooler and cooler and cooler. And then on the final, when we finally run it back into the mechanical oscillator itself, there's a heat expansion unit or a heat exchanger, which is not taking heat and putting it out. It's actually drawing and heating the air up, heating the fluid up at that point.
Without any outside power?
Initially, when you get it running, you're running it initially with the compressed air. Once you begin the compression stage and it gets to liquid air, then it's running itself. You're putting it through the heat exchanger, that expands it, and then the unit's running itself.
There's no such thing as perpetual motion?
Oh, it works. All I can say is that we've been doing the testing with it, and 3 pounds of, I think it's 3 pounds that he said. 3 pounds of liquid air give 10 pounds of liquid air put through the heat exchanger. The actual expansion of it, of the liquid air, allows, each time we take the work out of it, it virtually restores or gives the power back in the form of mechanical motion. So we're actually just taking the power, so to speak, out of the air.
Jordan,
Yes?
how do you convert the linear motion into rotary motion?
He said, how do you turn linear into rotary motion? Rotary in what sense? If you want to.
Back and forth?
Yes. Yeah.
So if you convert that linear action into rotary,
Into a pump.
you know, for moving transmission or anything.
Okay. What Tesla did, Tesla stood it up on end, took the shaft, and then put the shaft on an eccentric. He also had an electromagnet on that same shaft, so that you can be excuse me, generating power at the same time. It can be used. There's so many different uses for it. I mean, it's when I saw it, I looked at the fellow. I said, "You don't know what you've done." I said, "That's amazing." And he's looking at me and said, all he's thinking about is the liquid air for running his smelting operation, and taking the other gases out of the air and that type of thing. But when he started, I have like I said, I have an actual tape where he explains it a lot more fully than I can, and. Sure, and basically what we're using is the actual pumping motion.
Are the questions? I feel that I think maybe we ought to close now and have those people that want to ask these questions, because these questions are not getting out over the whole audience. There's people out there that are not hearing anything except your answer, and they don't know the question.
Okay.
Maybe we ought to close and let those come up close around here if they want to do that. And do you folks back there want to be able to see it closer, or and if we close 10 minutes early, you can do that and still have time to be ready at 5 o'clock. Anyway, the idea is, as you said, you put in 3, get out 10.
Yeah, so 3 gallons of liquid air will produce 10 gallons of liquid air when put back through the heat exchanger. So for every 3 gallons that we use, 10 gallons of liquid air are being returned for use.
I'm sure that interests some people rather distinctly, and you'd like to discuss it more personally. Now, let me repeat. Do you need directions again as to what to do? We meet out here at 5 o'clock at the grand ballroom door, right up these 2 flights of stairs to the left here. You have time to come up here now. You got about 30 minutes. And 4 of those change, whatever you want to do.
But then he showed me he actually took thermometers and said, watch, and I was astounded because I always thought the compression should get heated, but it doesn't. It doesn't. You can feel the air when it comes out. The air actually coming out here will be cooler than that compressed air that's going into it.
Okay, you must admit a smaller quantity of air than the expanded volume of the piston.
No, because see the piston, it's on both sides. See, right, it's one piston. The piston, when it's over here like this one's open, this is totally closed. When it goes back this way, this one's closed, this one's totally open. When it's here, at the middle, you can see, just barely sealed, just a small space on each side. Okay, so that when it's all the way over, that same air is under so much pressure. I mean, when you put the pumps on it, that air comes out of there under pressure, and then it goes through 4 stages. By the time it goes through the 4th stage, it's liquid. So.
And this machine drives the pumps?
The pumps, after the 4th stage, it goes back around through what I call a heat exchanger, but it's basically an expander.
But the machine drives the pumps.
Right.
Okay.
Right.
So you're actually.
Yes, say you're actually using the one piston to drive the 2 pumps and to run the electrical or the mechanical oscillator. It's doing all 3.
No, I didn't.
Start winding that up. Right now it's not even 25. It's more like 15. This is what's going in. Exactly. What's coming out is right here. You can feel it. Feel the air. It's cool. It's actually cooler than the air going in. The total amount of air that goes in is the total amount of air Yeah, we're running about 10 pounds of pressure. 10 pounds of pressure. You get when you start turning that up to 25, 50, 70, forget it. Feels great. Yeah, it's. Let me just see. Let me see if we can get it going.
How much thrust does this generate?
Right now, the only thing that changes is this. No matter how they're going up 10 pounds, no matter. We had right up behind. We took super mag. We took super mag. We put it on some coils, and it doesn't affect it at all. I mean, you don't see any reduction. You don't see any reduction at all. I mean, that's 5 to 7 pounds of pressure. I wish we could get it up to like 75 pounds or something. I could stand on it. Jerry Decker could stand on it, and 2 or 3 more guys. It would take us all around this place. It's very, very powerful. We used an oxygen tank and ran it up to 100 pounds and 100 pounds. It was screaming. Well, I have a New York. It's 75 pounds. Excuse me? What? I just want to do the liquid air material. I don't have enough of an engineering mind to figure out the rest of it. I just knew that we wanted to do one of Tesla's devices to see where the man was at, to see the reality. And everything he said in his patent was exactly right. It was perfect. Full letter. It was amazing.
Smile, Dickie. You're on camera.
Now there's 25 pounds of pressure. That's 10 pounds of pressure. Plus, if you stand on it, it's a great massage unit. Yeah, right. That's what I told him. I told him to miniaturize it, and then we could sell it as a vibrator. Be the only one in the world that went, well, never mind.
I'm just talking to Harry